We'll see the units because in energy scenario, the conversion of energy from one unit to another unit is very crucial. So we'll see the unit conversion. So first one is how to convert, right, kilowatt hour into megajoules. So energy in kilowatt hour, if you multiply with 3.6, it becomes megajoules. Then you have the BTU, so right, British thermal unit. How to convert that into joules? You have to take, if energy is given in BTU, you have to multiply with 1055. Then tons of oil equivalent tow. To convert that into gigajoules, you have to multiply with the factor 42. Similarly, tons of coal equivalent, which is also known as TCE. To convert that into gigajoules, you have to multiply with a factor 29. Then BOE, right? That is billions of, barrels of oil equivalent. That to be converted into gigajoules, we have to multiply with 5.7. Then there is another unit called quad. So to convert quad into exajoules. So quad is nothing but 1 exajoule is also known as quad. Okay. So now we all know what is meant by kilojoules. Kilojoules is 10 power 3 joules. Megajoules is 10 power 6 joules. Giga is 10 power 9. Tera is 10 power 12. Peta is 10 power 15. Exa is 10 power 18. And zeta is 10 power 21 joules. So let's see a problem, small problem. So on average, US single family home uses 114 gigajoules of energy annually. Convert this annual usage into tons of oil equivalent. That is two. So as we have seen in the previous page, 1 tow is 42 gigajoules. So energy in tow is given as energy in gigajoules divided by the conversion factor, which is in the unit gigajoules per tow. So as per this, given value is 114 gigajoules, 114 gigajoules by 42 gigajoules per tow. So if you do the conversion, you get 2.71 tow. Similar, there is another problem where a consumer uses 500 kilowatt hour of electricity in a month. Calculate the equivalent energy in megajoules and joules. So as we know, 1 kilowatt hour is equal to 3.6 megajoules. 1 megajoule is equal to 10 power 6 joules. So 500 kilowatt hour into 3.6 will give you 1800 megajoules. So how to represent this as joules? Either for megajoules you can put 10 power 6 joules, or you can just take this and represent this as 1.8 into 10 power 9 joules as well. Both are correct only. Now, as we know, 1 tow, that is ton of oil equivalent, is approximately 42 gigajoules, and 1 gigajoules is 277.78 kilowatt hour. Also, 1 gigajoules is equivalent to 10 power 9 joule. So 1 million tow is nothing but 1 m tow. 1 exajoule is nothing but 10 power 18 joules. So now having this, we'll see next problem. A power plant produces 2.5 into 10 power 9 kilowatt hour of electrical energy annually. Convert this energy into megawatt hour, million units, gigajoules, terajoules. So electrical energy given in kilowatt hour as 2.5 into 10 power 9. So 2.5 into 10 power 9 kilowatt hour, if you want to convert this into megawatt hour, you have to just divide it by 1000. So it becomes 2.5 into 10 power 6 megawatt hour. So as we know, first one is we need to convert this into million units. So we know 1 million unit is 1 unit is 1 kilowatt hour, right? So 1 million unit is 10 power 6 kilowatt hour. So if you divide this megawatt hour into 10 power 6, you get 2.5 into 10 power 3 mega unit, or simply saying 2500 million unit. Okay. So next thing is converting kilowatt hour into gigajoules. So we have this conversion. 1 kilowatt hour equal to 3.6 megajoules. So 2.5 into 10 power 9 into 3.6 will give us this much gigajoules. You can represent it as 9 into 10 power 9 megajoules or 9 into 10 power 6 gigajoules. So next is gigajoules to be converted into terajoules. So as we know, 1 terajoule is equal to 10 power 3 gigajoules. So from this we can directly take, right, 9 into 10 power 3 terajoules, which is also can be written as 9000 terajoules. Okay, so the simplified explanation is given on the right hand side also. So next is an industrial boiler consumes 4.2 into 10 power 12 kilocalorie of thermal energy per year. Convert this energy into kilowatt hour, gigajoules and terajoules. So as we know, 1 kilocalorie is equal to 4184 joules. And also 1 kilowatt hour is equal to 3.6 into 10 power 6 joules. So now first convert to joules. So 4.2 into 10 power 12, if it is multiplied with 4184, we get in joules, this much joules. That is 1.757 into 10 power 16 joules. Now this has to be converted into kilowatt hour. So convert to kilowatt hour. To convert that into kilowatt hour, we have to divide it by 3.6 into 10 power 6, which comes as 4.88 into 10 power 9 kilowatt hour. Also, to convert kilocalories into gigajoules, right? So 1 gigajoule we know it is 10 power 9 joules. So already we have in the previous step 1.757 at 10 power 16 joules. So you make the necessary conversion so that you can represent as gigajoules. So this 10 power 16, I am writing it as 10 power 9 into 10 power 7. So this 10 power 9 into this value I can represent as gigajoules. So this 10 power 7 is the remaining thing. So this is 1.757 into 10 power 7 gigajoules. Then converting kilocalories into terajoules. So again I am taking the previous value we got 1.757 into 10 power 16 joules. So you just I am writing the 16 as 10 power 12 into 10 power 4. So that gives 1.757 into 10 power 4 because 10 power 12 is tera. So 10 power 12 can be represented like this, right? So 1.757 into 10 power 4 terajoules. Okay, next conversion problem. Coal has a calorific value of 4200 kilocalories per kg. Express this in megajoules per kg, gigajoules per ton. So first one is kilocalories per kg to be converted into megajoules per kg. So kilocalories you have to convert to joules first. So 4200 is given. So 4200 into 4184 joules will give us 17.57 into 10 power 6 joules. Okay. Or it can be written as 17.57 megajoules per kg. Now this 17.57 megajoules per kg should be converted to gigajoules per ton. So we all know 1 ton is 1000 kg. So you just multiply, we get 17.57 gigajoules per ton. Okay. So next important thing is plant load factor. So PLF. So PLF is a measure of the output of the power plant compared to its maximum possible output over a specific period. It indicates how effectively the plant's capacity is being utilized. So high PLF means the power plant is running close to its full capacity for most of the time, while a low PLF suggests the plant is either idle or running at a reduced output. So we can represent PLF in percentages actual energy generated in kilowatt hour divided by maximum possible energy in kilowatt hour multiplied by 100 because it is represented in as percentage. So to get the maximum possible energy, you need to multiply the installed capacity in kilowatt with the total hours in that period. So let's solve a simple problem on PLF. A small power plant has an installed capacity of 100 megawatt. In a single day means 24 hours, it actually generates 1800 megawatt hour of electricity. Calculate